Elements. But what are they? An element, or chemical element, is the simplest form of matter that cannot be further broken down using any chemical means. Each element has a unique number of protons. Because of this, you can tell them apart, because they have different properties. But let's discuss more with Dr. Boren and Dr. Francium.
Hi, Jennifer. Yes, this is Dr. Francium, and I'm out here in the MIT campus, in a location I cannot disclose. But I can tell you it was right here where the elements were discovered. But why don't we go first to the lab, where I can tell you more about what this is all about. Come on. Welcome to the lab. Come in. This is the periodic table, the way the elements were arranged. This was made by our top scientist here at MIT, Dmitry Mendeleev. Chemical behaviors were originally led scientists to classify matter into elements. But what is chemical behavior? Chemical behavior is how one atom relates to another atom. This depends on the number and type of chemical bonds they can make. The bonds depend on the number of electrons the atom has and how they can interact with each other. These bonds are signified by the pegs. However these interact is called their chemical behavior. Atoms with the same chemical behavior are then grouped into elements. As we can see in the table, there are many of them. Atoms in the same group have the same number of electrons in their outer orbitals, but they don't have them in the same arrangement. That's what makes them different. Atoms in the same column have the same chemical reactivity, or one that is close to each other. The whole table is arranged so that they have increasing atomic numbers. For example, we start from 1 and we go all the way until 106.
The elements, they have a number at the top, which is the atomic number, which is the number of protons in an atom. The number at the bottom is the atomic weight, the total mass of protons and neutrons and electrons in a single atom. The names that are given, or chemical abbreviations, can be in Latin names, ferrum, for example, or Greek words like phosphorus. They are found in Berkeley, and one of our famous scientists is Einstein.
The first group of elements I'm going to talk to you about are noble gases, which are located over here.
Then we have noble gases. These were discovered by Henry Cavendish by chemically removing all the oxygen and nitrogen from a receptacle containing air. They're also known as rare or inert gases. All gases are at room temperature. They're mostly non-reactive, not likely to lose or gain electrons. They're colorless, non-flammable, odorless, and some examples can be neon, which is used in science because it glows when electricity passes through it. Helium is another example, which is less dense than air, used to balloons to float. And argon, which is inside the lava pools.
Hello there, I'm here with Dr. Francium. My name is Dr. Boreal, and I will help her explain the elements. The first group that will be explained will be the non-metal group, which is indicated by this yellow color right here.
Oh, and don't forget this one.
How can you forget hydrogen?
Non-metals. Their characteristics include the fact that they're brittle, they're not marble, cannot conduct heat or electricity well, and accept electrons in chemical reactions. Some examples of nonmetals include selenium, which is for the production of glass, and phosphorus, which is the matches, the black part, the one that's lit.
The group that will be explained will be the metal group, which is indicated by this light blue color.
Moving on, we have metalloids, also known as a semi-metal group. Some of their characteristics include the fact that they're only partially conductive of electricity. They're in a solid state, and their lustrousness. Also, there are only 6 of them. Some examples, as we use them in real life, are carbon, which is charcoal from heating things up, such as a grill. Then we have silicon, which is semiconductors for microchips in computers.
The next group that will be explained will be the metal group, which is represented by this dark blue color. The metal group is the most abundant of the element group.
Metals, the most common group of elements in the periodic table. Their well-known characteristics include their solid state. Mercury is not solid under standard temperatures and pressure conditions. Metals are shiny, good conductors of electricity, malleable, and can easily give out electrons. Some examples are mercury, which is used in a thermometer, and copper, which is used in wires because of its good conductivity.
We'll be back with breaking news in just a minute.
Hello, this is Miss Molas again. Here we are in another segment to make your life happier and full of joy. I love you, my little bird. Let's keep the joy getting to all those corners in the world. Let's keep the jokes. So, next caller. Yes? Next caller, please. Okay, so the question. What is the name of 007's chemo cousin? Polar Bond! Ha 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 ha! Ha! Oh, okay. Next person. Okay, so do you know the word for silicon in Spanish? Sí. That's hilarious. What is the chemist's favorite kind of tree? Yes, tell me. Chemistry! Remember that the most important lesson in chemistry is never lick the spoon. Remember that, guys, and that will save your lives.
Welcome back, this is Jennifer Avery, and we are in breaking news. We're going to keep talking about the elements. Let's go back to Dr. Francine and Dr. Boyd.
Will be the alkali group, which is represented by this light pink color.
Alkali metals. These metals have characteristics that include high reactivity. They're bitter to taste, slippery, malleable, and good conductors, but softer than most metals. They can even be cut with a knife under room temperature, like butter. Also, they can explode if they're exposed to water. The explosions get bigger when the mass is larger. An example of alkali metals is potassium, which is used as a component in baking powder, which is responsible for the spongy nature of bread.
Next on will be the alkaline group.
Arriving as a group 2 in the periodic table, they're the alkaline earth metals. Their characteristics include the fact that alkaline metals are very reactive. They have 2 electrons in the outer shell and they're solid, shiny, and in the form of cam, bond very quickly. An example is barium, which is used in radio contrast dye to make organs like the intestine be visible under the X-rays.
That was it all for me, and I'm going to pass you down to Dr. Francium for her to explain 3 groups.
Thank you, Dr. Borean.
Lanthanide, collectively known as the rare elements in Earth, isolated from minerals. Their low ability in the biosphere. They are not known to naturally form part of any biological molecules. Their low toxicity. The reduction of glasses, batteries, and magnets, lasers, and petroleum are examples of these. They're soft metals, silvery white and oxide when exposed to air, highly reactive and burn easily in air. Can be used to separate H from water molecules. Then we have actinide, the 14th radioactive element named after the element actinium. They're all radioactive and highly electropositive, have a tendency to release electrons. They tarnish quickly in the air, very dense. Actinides combine directly with most nonmetals. They dominate the study of nuclear chemistry, used to fuel nuclear power plants as a component in the nuclear weapon, Nagasaki, uranium, the bomb, and also they contribute to the cancer therapy and to peacemakers.
Summary. What are the elements? They are the simplest form of matter that can't be further broken down using any chemical means. Why are they arranged this way? Each successive element in a row has a higher atomic weight than the one on its left, and the elements in columns have similar chemical properties. What patterns are there in this mystical layout? Atoms that have same chemical behavior are grouped into elements. Elements in the same group all have the same number of electrons in their outer orbitals. Remember, never lick the spoon.
I hope you enjoyed learning about the elements. Back to you, Jessica. Goodbye.
Good luck and prosper. Bye.
Thanks for watching. That was all for today. Special thanks to Dr. Boring, Dr. Francis, and our production crew. This was Breaking News.